Okay, if there's no other announcements, I want to introduce this week's seminar speaker, someone I'm really excited that we got to come in today and talk to us. His name's Bill Allis. So he's a vice president and water practice leader for Gannett Fleming. They're based out of Harrisburg. They're a infrastructure do infrastructure work, civil, water, transportation. Bill wanted me to add that they're always looking to capture top engineering talent, both as interns and professionals. So if you're interested in internship experience, this will be a good talk for you today. So Bill's been working for 34 years, diversified in the water field. His technical expertise, which he wishes he could do more of now, includes water quality assessment, treatment process selection and optimization. He's done master planning, facility rehab, and facility expansion, primarily in the eastern United States, from New York down to Florida. His current responsibilities include managing the engineering operations of Gannett Fleming. So he's now in a much more of a managerial role. Right? He's also the water practice leader, so he plans for and directs the business growth through new talent and business acquisition. Brief interesting story, so Bill's engineering roots started right in our neck of the woods. So in 1982, he was working on the then new Johnstown water treatment plant. Anyone ever drank water in Johnstown? All right, so you're familiar with Bill's work. All right. But now Bill's, in the later stages of his career, and it's a Friday afternoon time slot, and so it's really not that well suited to technical discourse in his opinion, and I think we all might agree with that to some extent. So Bill is going to discuss consulting engineering and the concept of forces of change that have shaped his career. And he also looks forward to hearing what we think might be the forces for change in the distant future for those of us that are maybe just starting our careers. So please join me in welcoming Bill Allis.
Hope this goes well. We'll see. I'm sort of out of my element here in the classroom. It's been a while. I hope you all appreciate how lucky you are that you get these 4 years to sort of chart your path forward and learn from your esteemed professors. It's a great time of life. So, yes, I'm not talking about any research. I'm not talking about the greatest design I ever did or the greatest design Gannett Fleming ever did. I'm really talking about a career path that you may be able to enter into, which is consulting engineering. And looking back after several decades of work, kind of alluding to a concept of forces of change. What is it that's going to define your career? That is maybe out of your control, if you will. What's going on in society? What's going on sociologically, demographically, regulatory, politics, et cetera, that's really going to define what, as engineers, we're doing to contribute to the fabric of society. And basically, can you foresee that? Because I couldn't. I really couldn't even foresee being an engineer when I started, and I'll tell you about that a little bit, but to the extent to which you're able to sort of translate what's going on around you into what might be impacting your career in the future, the farther ahead you're going to be. But it's a real struggle because stuff happens, right? 9/11 happens and everything changes. So let's talk about that a little bit. But first I want to pander just a second just to say who Gannett Fleming is. We are a Pennsylvania rooted company. We're headquartered in Harrisburg in central Pennsylvania. We have about 800 people there. We got about 2,000 people total nationally and in a few international sites. So we're over 100 years old. We do everything from soup to nuts in engineering, and then we also have a geospatial information management company, as well as do management consulting and rates and valuation. One of our former engineers talked to you last week, by the way. I worked with Jim DeWolf for several years in Harrisburg. About 20% of our company is water. A large share of it is transportation, and then we also do sort of vertical construction facilities type work and power. And we're about the 17th ranked in terms of overall revenue. And we're about a $350 million company in revenue a year. So me, I did not take the traditional path to engineering at all, and I'm glad. I got a bachelor's degree in religion from Dickinson College. I spent, 1 year, my internship, I worked in a Catholic hospital in a psychiatric ward with nuns for nurses. I worked as a veterinary assistant. I became a blacksmith or a farrier. I did archaeology and construction, and then landed in the land surveying field. And that ended in 1982 or 1983 when the recession hit. And you know, we all just suffered through a pretty bad recession. Those are the types of things that are really going to be potential forces of change in your career. But for me, it was lucky because I ended up going to an engineering firm. Went to Gannett Fleming in 1982, and it took me several years to figure out that I could do what the engineers were doing, so I went to engineering school. I got Gannett Fleming to finance my education. Went to Penn State Harrisburg, and then was lucky enough also to fall into a field that I loved, which was drinking water process engineering. And the cool part of that for me was that we were the first guys that got our hands on the projects. We actually defined the projects that we're doing. So we were doing the work from, you know, understanding the problems that the municipality may have had to, you know, translating that into what a facility might be like, what the process might be to address the type of source water that they had, and to work with the regulations. So that was really the first 15 years of my career. I took a short detour with Mr. Goodwill, went to another firm for a couple of years. I knew Joe, and I guess he just told me at lunch when he was, I don't know, 25, 26 years old. Now, he's so much older than that now.
28.
He's always been the same now. But then I went back to Gannett Fleming. I became the National Water Practice Manager for the company in terms of you know, dealing with the technical and quality aspects of the engineering, water engineering there, and then evolved into the business line leader, where now I'm both managing operations and really charting company strategy moving forward. And so to do those last things, you know, when you're in this first part of your career, you got your head down, you're looking at what you're doing, you're being creative, but you're crunching numbers, you know, you're developing drawings, you're writing specs, you are communicating with your clients and regulators, etc. But if you're lucky and if you're smarter than me, you're really looking around at the world and thinking about why you're doing what you're doing. But for the most part, younger engineers have a tendency to just really sort of focus on the work that they're doing without thinking holistically about, you know, what's going on with infrastructure, what's going on legislatively in government in terms of financing the type of infrastructure work we want to do and that kind of thing. And so those types of things are what you really need to have your finger on the pulse of when you're trying to chart the path for your company. So I did look at your website briefly, and so I don't know whether you guys have looked at this since you applied here, but there is a Franciscan approach to engineering, and it's really a Franciscan approach to engineering education, I think it's awesome, because I'm going to hire a new engineer that has internship or co-op experience, likely, before I'm going to hire one that doesn't. So I buy in totally to the concept of combining classroom and project experience during the education process, because I know you're going to know sort of what you're getting into, you're going to know what you want. But anyways, you know, your website says this is what you do to become a successful engineer. So that's a simple statement, but you know, in our area, really, what is a successful engineer? So we have a role in society, okay? We're not just simply technocrats. So to me, my view of success is in the water resources area, is ensuring public health with safe and clean water, and those are in quotes because one's the Safe Drinking Water Act for drinking water, and the other is the Clean Water Act for wastewater. That's what we do. As professionals, we're going to have as great, if not greater, impact on public health as people in the health field. And you can have that debate with your colleagues or co-students that are in the health sciences here. But we have an awesome impact on that. And we're solving communities' problems with cost-effective, innovative solutions. That's the fun part. We're really optimizing infrastructure life cycle, supporting economic development and growth, and preparing for the future without stressing the present. When I wrote this, by the way, just as sort of a political interlude, this is like the way that a Democrat would organize these. I think a Republican might maybe organize them in the opposite order. But economic development is, you know, important part of what we do in the infrastructure arena, as is public health. So that's my sense of success. Now, consulting, I know how to use Wikipedia too, so I was able to like look that up on Wikipedia. And I did study Latin in high school, but anyways, it was interesting to me to see that consulting is really from that consultare, to discuss, and that really is the crux of what we do. I had a slide on communication. I don't think I put it in here, but communication, both the active listening and active speaking, report writing, etc., is critical to your success in this field. But a consultant is experienced in a specific field. It's a subject matter expert, provides expert advice. You're the trusted advisor of your clients. So what's the value proposition for that versus engineering as a commodity, which we don't want to be? If we're business people, we don't want to be the low-cost engineer, right? We want to be the engineer that is bringing value to our clients. And so that the business side, I mean, we can actually charge for value, the value that we offer our clients, not just the hours that we give them. So we're giving them expertise that they can't afford to have themselves in-house, okay? Every municipality can't have an experienced process engineer in it. It can have great operating staffs, but it can't necessarily have somebody that's well-versed in all the different processes that you may be able to select to do a certain drinking water treatment problem. It gives our customers instant access to that experience. It allows us, because of our breadth of understanding, to provide more innovative solutions. We've made a lot of mistakes, probably more mistakes than our clients have, so now we know how to avoid those mistakes. And we're positioned to address forces of change. And I'll get into that a little bit more. So what we do in this field, there's really a ton of work to do and a ton of things that you can be involved in. So we have, starting up here and going counterclockwise. I'm not really sure why our marketing people made this cycle go counterclockwise, because that's not the way I think. But, at Gannett Fleming and in this field, source water, we do development, we do dam construction for impoundments, We do intakes for extraction of water from both surface water and groundwaters. We do a lot of computer modeling for yield management, safe yield from different reservoirs or systems of reservoirs, and protection of those resources. My area was drinking water, treatment, pumping, transmission, storage, distribution, and then managing the residuals from those processes. And then the reclamation side, the wastewater side, from pre-treatment through all the biological, advanced and primary chemical treatments, and then up into the more environmental aspects, the stormwater stuff, flood control, stream restoration, remediation, protection. So that's the whole sort of cadre of work that we do in this field. You probably knew that already. But so now let's talk about forces of change. I'm really not going to be talking that long. I'm really looking for this to become a discussion. So in putting this slide together, I did it as quick as I could, but there's really, as we do work, our clients come to us with a problem or a need. And then we try to address that problem within a certain environment, a business environment, if you will, a political environment, a social environment. And then we come up with a solution, and that's, that is also impacted by the potential technologies maybe that we have to address the problems. So, what changes in society create need? And what business environment sort of attributes constrain or enhance our work process and the business climate? And, what technologies might impact our ability to derive solutions? So I put together just to sort of help us think about this, or these are things that impacted me, or the whole industry during my career. Probably the biggest one in terms of problem need was regulation. I mentioned the Safe Drinking Water Act, the Clean Water Act. The Clean Water Act in 1973 got a kickstart to a lot of environmental engineers designing new wastewater treatment plants. The Safe Drinking Water Act and the Surface Water Treatment Rule got us upgrading and creating new filter plants. And the response needed to these regulations might span 10 or 15 years of your career trying to make those infrastructure improvements. But there's other things too, events. MKE refers to my hometown, Milwaukee. Okay, so Milwaukee had a cryptosporidium outbreak that created a whole litany of regulatory amendments that created work for another 10 years of my career. Flint, Michigan, as you guys go out into the industry, that's what you're going to be dealing with. You're going to be dealing with addressing lead issues from legacy pipeline materials or plumbing materials, if you will. And public opinion will have a huge impact on what you're forced to do, whether it's right or not. Whether they interpret what happened in Flint correctly or not, our legislators and the political atmosphere is going to be guided by public opinion in response to some of these events. Population shifting and demographics. The three biggest growth states projected over the next 10 or 20 years in the United States are Florida, Texas, and California. Okay? You want to do work in our area with new infrastructure, that's where the growth is going to be. Workforce demographics. That's something maybe that Jim touched on last week, is that our clients are losing their operating staff. They're like me. They're a year or two away from retirement. Okay, and that's a big deal. Climate, whether you agree with it politically or not, the intensity of storms that we're seeing, the effects of Superstorm Sandy on infrastructure in the Northeast, is going to take us 10 or 15 years to respond to in terms of affecting storm hardening changes. And aging refers to infrastructure, not population, or not me, but aging infrastructure is something that we're playing catch up on. And you know, there's not enough money in our economy for us to replace the infrastructure as quickly as we need to. So we're just gonna keep at it as best we can, but aging infrastructure is a huge driver. So politics, environmentalism, health science, economic growth, recessions, decline, state and federal funding, that's really the business environment that you're going to be working in. And probably the most important there is the funding, okay? You know, we have communities all over the United States looking for federal support and state support for drinking water infrastructure or wastewater infrastructure. And honestly, they're not going to get it. I mean, we all know that our politicians are unwilling right now to provide money for that. So our infrastructure improvements are going to be revenue funded. That means ratepayers got to pay for it, okay, as best they can. Although both of our political candidates agree on one thing, and that is that they need to shore up infrastructure. So we'll see. But the days of federal handouts to do like a 1970s pollution control type of infrastructure development, I don't foresee that happening. And then solutions, I mean, this is the fun, sexy part of engineering, right? Is the technology and the research stuff. You know, where are we going with membrane filtration, both high and low pressure? Where are we going with advanced disinfection processes? You know, how do those help us address problems? And the issue of competition and trade, competition really has to do with the affordability of some of the equipment that we try to use. If there's competitive pressures, you know, it's obviously much more affordable as things are developed, you know, by a technology firm that become applicable in the marketplace. They're high priced for the first couple of years until those patents run out or competitors catch up with that technology. So to me, those are examples of forces of change. So, you know, your guys' problem and my problem right now in trying to direct the company is, you know, what are we looking at over the next, you know, the next 40 years of your career? Just want to amplify this and maybe get you to think about some things. We do dam construction, dam design, dam engineering. I mentioned climate. So climate change is potentially driving the need for spillway improvements on dams, okay? Because the intensity of storms are increasing, the probable maximum floods that occur in a watershed, you know, may be increasing. The whole concept of probable maximum flood as opposed to designing for a 100-year storm, there's a huge difference in the amount of discharge. And states like Virginia are looking closely at that and saying, well, we want you to upgrade your dams for probable maximum floods. And so a lot of those dams are in a position of having to be rehabilitated. That could be a huge driver for work in our industry. Environmental regulations and the construction of dams. You know, I was just in Denver. They're looking at doing an upgrade or raising of a dam, Gross Dam for Denver water. That's been in the permitting process for 15 years. We're not doing run-of-the-river dams anymore very easily, but it's driving us into different solutions. So we're seeing more pump storage dams or dams or reservoirs that are off-stream that we pump from high flows in the rivers when it's available into those reservoirs, and then discharge when river flows are low. Now, those are even getting hard to get permitted. So we're also looking at things, and this is really cool, quarry storage. So in the Potomac River Basin, instead of building a side stream pump storage dam, we're repurposing granite quarries, which are really tight, don't have a lot of groundwater infiltration, and using those for water banking, if you will, or storage that we will, unfortunately can't release by gravity, but would pump out for use during low flows. Water intakes to get to the dams or to get to the water treatment plant. There's big impacts from fisheries and the environmental community on the way we design screens for these systems that are frankly increasing the cost of these systems significantly. But states are now writing regulations around the screening technology that's available in the marketplace, even though it may be fairly impractical to use. We're using screening systems for huge intakes that have 1 millimeter slot openings, so pretty skinny. Forces of change in drinking water. The giardiasis outbreak in northeastern Pennsylvania in the late 80s probably drove 15 years of work for our company. Pennsylvania had the highest number of open source water reservoirs that were directly supplying drinking water supplies with just disinfection in the country. We had to filter all of those plants, and that took a fair amount of resources and a fair amount of time. But it was also cool because it drove the concept of exploring what we refer to as abbreviated treatment processes for drinking water. So because the supplies were pristine, they had turbidities in the neighborhood of 1 to 2, we were drinking them, right? We were able to put filtration processes in place there that didn't require sedimentation. So we were able to build these plants for maybe half the cost we would have if we had been doing conventional plants. Membrane filtration, this is in response to the Milwaukee crypto event. The enhanced surface water treatment rule required enhanced disinfection. So we had plants looking at that were on source waters that might be classified above bin 1, which is the best, and bin 2, bin 3, bin 4. Are you guys familiar with that terminology? Well, it's based on year-long water testing and the incidence, I hope that's the right word, incidence of cryptosporidium in those samples. And if you're above a certain level, if you're below a certain level, you're bin 1, and then you just need conventional disinfection, filtration disinfection. If you're in bin 2 or 3 or 4, you need advanced levels of disinfection. So that regulation drove certain plants to look at using either membrane filtration or UV disinfection for cryptosporidium disinfection or removal. So that was a driver. That same regulation eliminated open finished water reservoirs. In some cities like Baltimore and Pittsburgh and others, we were treating water and putting it in an open reservoir. Well, go figure. I'm not sure why they did that in the first place, but it was getting contaminated. And membrane filtration actually in the Highland Reservoir in Pittsburgh provided a great application for membrane treatment of the water from the finished water reservoir in response to public opinion and public outcry in closing that reservoir because it was the gemstone of an urban park. So the people with the big houses that lived around the park didn't want us to close the reservoir, so we had to come up with another solution. And frankly, we were able to design a membrane filtration plant fairly economically and architecturally well suited to the park. Do you know this park?
Yeah.
Okay. So that was a driver. So climate change drives not just storm intensity, but also drought conditions. So I had a water supplier that had been my client for 40 years that all of a sudden started to have horrendous taste and odor problems that were concurrent with low water flows in the Lehigh River. And that drove them to have to look at new technologies to add on to their plant. Well, their plant was aging, so they decided to build a whole nother plant. And oh, by the way, while they were doing that, you know, they were sort of on the cusp of this sustainability movement and wanting to have sort of a more sustainable future charted out in their vision and be able to sort of sell this investment to their public. So this was also the first LEED registered water treatment plant in the United States. Not that, frankly, it was really sort of a branding issue more than anything else, because it's hard to do meaningful LEED design for a building that only has 3 or 4 people in it. That's the cynical side of me. Groundwater depletion, that's another, you know, kind of climate driven, but also population driven. We're doing too much extraction from our groundwaters. We're being forced to use groundwaters of more marginal quality. But in this particular application, and this is near Lancaster, Pennsylvania, we're able to use high pressure membrane treatment to be able to use a groundwater that had high total dissolved solids in it that otherwise we wouldn't have been able to use. So there's a technology driver. And I think this is my last slide almost, but here's one that I think really may pique your interest, okay? So maybe you know about the Chesapeake Bay Initiative. I hope you do. You're probably, talking with Joe, you're in the upper reaches of the Chesapeake Bay watershed here. I think probably the watershed goes to the Potomac, but I'm not sure. But it goes into the Chesapeake. So the Chesapeake Bay Initiative was to reduce nutrient pollution in the Chesapeake Bay. And there was a 5-state compact, and they decided that the first phase of improvements they would do would be eliminating or minimizing point source pollution. Well, point source pollution, and I'm just using round numbers here because I don't remember the real numbers, but the point source pollution was maybe 20% of the pollution load going into the bay. The other 80% was from agriculture. Well, we don't govern the agricultural community very well in this country. So so the first thing that we did was we poured millions of dollars into upgrading wastewater treatment plants with enhanced nutrient reduction technology, which is great. I'm not saying it's bad. I'm just saying, had we taken that many millions of dollars and put it into restorative watershed improvements on farms or educating farmers and things like that, we may have eliminated a lot more nutrient runoff into the bay. So the question is, from my perspective, is we did great work here, but did we really follow the right path? Was our policy right? Okay, so environmental policy, governmental policy is incredibly important to what's going to drive your business, but don't be afraid as an engineering community to have a voice in that. We alone did 15 wastewater treatment plants, so we got a lot of revenue out of it. And I think another reason actually that we did it is because we didn't need as much government funding. We had the ratepayer revenue stream paying for these improvements. We weren't going to get farmers to pay for that. We would have had to inject resources into the agricultural community that we couldn't get any other way other than maybe raising taxes or putting restrictions on them that they weren't going to take very easily. And I think in your future, the balance between municipal waters and agricultural waters is going to be a huge issue that needs to be worked out. I mean, just look to California, okay, where 80% of the water supply goes to the agricultural community. Okay. Another place to look, if you're really sort of interested in what's going on, is Israel. Look to Israel and see how they addressed agricultural water use from a conservation and a technology perspective, and how they integrated that into their water policy, national water policy, along with, you know, their municipal or drinking water. It's really amazing, actually, how they put their national resources into sort of stimulating innovation to reduce consumption by the agricultural community. So, what do you guys think? What do you guys think is going to be impacts on you in the engineering industry over the next 40 years? I just put up a bunch of stuff here as I was thinking about it, because I think it's not, you know, I just touched on a couple of things, but there's so much change going on now that can impact you that you might not even think about, but that you need to think about. I mean, terrorism and earthquakes. Earthquakes in California, I mean, we could be working at recovering from those for decades. Terrorism already impacted our lives, the 9/11 stuff. But what happens? What happens if something impairs our water qualities associated with that? I mean, is that part of the world that you guys are going to be confronted with over the next 40 years? You got to think about it. Ocean outfall elimination, that's sort of a cool one, right? We're protecting the environment. In Miami, they need to reduce ocean outfalls by, you know, the volume going from the wastewater plants into the oceans by about 60%. So how are they going to do that? They got to replumb the whole system into reuse opportunities, into groundwater injection opportunities, that kind of thing. So that's going to be cool work. Contaminants are going to get more resistant to disinfection. What are we going to do then? Chlorine doesn't work anymore. What are some other ones? Genetics. I'm not sure what the example is there, what we can do genetically, but I do know genetic markers as an example. When Joe and I were working in Philly together, the Philadelphia Water Department was doing research on doing genetic studies on the contaminants that they were finding in the rivers, and then trying to match those to genetic testing they were doing up in the watershed to try to find out what the real sources of contamination were in the river. So will we be able to use, you know, research, technology, techniques that are coming out of that work to help us in our industry? I'm done talking. Yep.
Let's thank our speaker. So let's open it up. Ask Bill a question, or if anyone has a thought on what they might think some forces of change might be.
And I am happy to answer any questions about this, about the employment environment, jobs, stuff like that. You know, that's part of what I do also. So if you have interest there, actually maybe we can talk about those afterwards if any of you want to come up and just ask questions about that. But I really, we're convening a group of under 30 staff people in Philadelphia in mid-November just to talk about smart cities. In both in our facilities and our transportation and our water resources groups, we're bringing all the young people together who may have a better finger on the pulse of what a smart city might really look like to them. It's also partly because a lot of those younger people are moving into the urban environments now. should have seeded this with a couple of questions. You got a question, Andy? There you go.
How would you like implement changes to non-point solution sources, like reduce like low nutrients, without like creating economic hardships on like farmers?
Say that again, please.
No.
I didn't hear it, and I'm not sure everybody did.
Okay, so how would you implement changes to non-point solution sources to reduce like the flow of nutrients without creating like an economic hardship on farmers?
Okay. Off the top of my head, I'm not an agricultural engineer, but I do some farming. First of all, you need to be able to balance the economics of it to make it attractive to them. Okay, so a couple concepts there. Nutrient trading is one, which is already sort of in place in Pennsylvania. So if we can give farmers an incentive to develop nutrient reduction and then put that pounds of nitrogen, hypothetically, into a bank and then have somebody else be able to buy that from them because they're not meeting their nutrient reduction goal, then we create an economy. That's part of what Pennsylvania is trying to do. Not sure how it's great it's working because it doesn't, the farmers don't seem to be piling on. There are some corporations that have started like big turkey farming operations that have tried to bank some of their nutrient credits in that way. That's one thing. I think you have to also educate farmers relative to organic farming and the appropriate application of nutrients, for their farming anyways. And then I think you need to show them the value of riparian buffer improvements and how that will enhance their yields in some way or their loss of sediments, whatever. Yeah.
The side stream dams you said are used to retain water and then pump when the flows are low.
Yeah.
You said that they're hard to permit. Why?
Pardon me?
You said that they're hard to permit to the design.
Yeah.
Am I correct in that?
Yeah.
Why is that?
It has a lot to do with wetland impacts because we're inundating wetlands. So imagine the Potomac River with a small stream that runs into it, right? The side stream impoundments that we're talking about are going to be in one of the valleys where that small stream is, and that small stream is going to have certain environmental attributes, positive attributes in terms of wetlands and that type of thing. So we need to figure out how to replace those when we inundate. It's basically just environmental due diligence, I think, and working with EP or whatever the state body is to get that right. We can do it. It's much easier. It's much easier than run-of-the-river impoundments that are going to have a much greater impact. I had another thought on that. Can't think of it right now. I'll think of it in a second. Part of being a year from retirement.
I have another question.
Go ahead.
Do you think anything like pharmaceuticals or prescription pills would be something that 40 years from now the treatment plants will have to try to treat?
I think so.
Okay.
Yeah, I mean, so you're right on with sort of endocrine disruptors and household pharmaceuticals, yes. Yeah, I mean, we'll be looking at those at wastewater treatment plants and drinking water treatment plants and, where the right place to apply the technology will be a balance between impacts on us as consumers and aquatic life as inhabitants of the waterways. I think that one might be one that shakes out with a good technological advancement. And, you know, that would be more in your guys' arena, I think, in terms of, you know, where we are technology-wise, in terms of absorbing those compounds in our processes. Our processes, you know, right now apparently won't touch those unless they're attached to sediments or something that we're removing anyways. But yeah, I think that there's definitely work to be done on that. You know, and the pathway is for research and academics to help to address that, and then, you know, for the practitioners, because that's really what we are as engineers, is, you know, we apply these technologies. But if we have an event, if we start having a lot of two-headed bass swimming around, you know, then it's going to happen even faster. Or if we don't have any bass swimming around, you know, it's going to happen. It's going to happen even faster. So it's that public opinion, things happening. You know, I think the way we communicate now and sort of the crowdsourcing stuff and how that, you know, how you all communicate so quickly and thoroughly, and maybe sometimes accurately and sometimes not so much, I think that will have a big impact on public opinion and can really, may actually speed up the process of opinion impacting what the community demands.
We're out of time, so Bill's going to stick around for a little bit. If you want to talk to him about consulting engineering or maybe about potential internship or career paths, we've got some time for that right after this. Maybe we'll just kind of hang out in the lounge area. So let's thank him one more time.